And welcome to you folks. This is Mr. Callen coming to you with Chapter 2, Section 3, Computing Decimal Products. Hey, got a little feedback about the first chapter. We're going to try something new this chapter. We're going to see if we can just tape one lesson video a day along with the assignment. I got some feedback from students that 2 videos one day and then 2 assignments the next was just a little odd to handle. So hey, let's try it. Let's see if this works better. Again, every day I will post a video and a homework assignment. Now that also means if I try to stay a day ahead of you, perhaps you can do the assignment and then watch the next day's video so that when you come in, I might be teaching a lesson, but you're like, Mr. Callen, I got this. I watched the video yesterday, and you can start up your homework. We call that flipping a classroom, where you watch the video the previous day. That's kind of your assignment, and then you come in the next day and you got 35, 40 minutes to complete that assignment. But let's all experiment together. Let's just see what works best for you and for our class. Hey, go ahead and pause the video briefly if you need to see your answers for assignment number 8, pages 31 and 33. If you did not do that assignment, go ahead and fast forward. Come on back after you've paused and checked your answers. And we will be going over questions. You all know I love questions, so I will be looking for questions tomorrow or whenever I see you in class again. Let's go ahead into our lesson, our learning target. You should leave this video or at the end of the assignment thinking to yourself, I now know how to multiply decimals and use a shortcut to multiply by powers of 10. All right, go ahead, name, date, period. Some of you doing this on the 31st. Of course, this is not the year 18. This will be 2020. Hour, page 35 and page 37, computing assignments, computing decimal products, assignment number 9. Now, I tried briefly talking to you. We need to do a better job of this, of writing the directions. I'm asking you to write the directions. From now on, write the directions, along with problem, work, and answer every time. But I shouldn't really say every time because we're studying mathematics. We know there are exceptions to every rule. So for instance, do not write down an entire word problem. That is an exception. You do not have to write down the problem. You would only show your work and your answer. Also, you'll notice my special directions for numbers 29 to 47 odds, and that is when you're asked to use mental math, I'm gonna tell you do not show work. So in that case, you'd write the directions, you'd write the problem and your answer down with no work. All right, so 29 to 47 odds, you will only write the directions, write the problem, and your answers. Pause for a moment, go ahead and title your paper, and then we'll continue. So multiplying decimals, many of you will remember this from 6th grade, maybe even 5th grade. I can't remember when you first learned it. Let's go ahead and just first, and this is a habit I want you guys to build. I need to build it as a teacher too. Always try to estimate, bring your number sense to this problem. So 3 and 77/100ths, that's about 4. 2 and 8/10ths is about 3. So what is 4 sets of 3? You're already thinking to yourself, this should be about 12. Maybe a little lower because 3 and 77/100 is smaller than 4. 2 and 8/10ths smaller than 3. So, but just keep that 12 in the back of your mind. Take that number, put it in your pocket, and let's continue. I know you guys know how to multiply digits, so I will show you the number. Now I want you to ask yourself, where will that decimal point go? Well, if you come back here, you'll count 2 decimal places in the first part of the product. There's 1 additional decimal place for the second number in the product. And so there is a total of 3 decimal places, and therefore the final answer should be 10 wholes and 556 thousandths. Now, a couple other things to remember. Remember, go back to your estimate. Remember when we said 4 times 3 is about 12? So look at all these possibilities, and these are just a few possibilities of where to put the decimal point in between these digits of 10556. But remember that our estimate was 12 and maybe a little lower. Only one of these answers makes any kind of number sense. Thousands or even 100, way too big. Not even a whole or 1 whole, getting closer, but 10 and a half is a reasonable answer using that estimation technique. So whether you count the decimal places or use your number sense in your estimate, I would suggest both. You should be able to place where that decimal point goes. On to another couple examples. I'm going to trust that you know how to multiply the digits. 6 and 7 make 42. 1, 9, and 7 would make 133. But where will the decimal place go? Pause if you want to think for it. We see 3 decimal places up here, so there should be 3 decimal places over here. Final answer is 42 1,000ths. And as a matter of fact, 1 decimal place, an additional 2 decimal places, 3 decimal places here for a final total of 133 thousandths. Now, interesting that these problems, how are they similar? How are they different? Well, clearly they have different digits. This guy's got 1 decimal place on top. This guy's got 3. No decimal places down here. This guy's got 2. And yet the major similarity is that both of these problems should have 3 decimal places in its final product. And moving right along to another example, again, I can trust that you know how to multiply these digits, but go ahead if you want to, press pause, work those out on your own. And when we multiply these and then add up the partial products, you'll get a total of 80 and 9200ths. There I go again, Mr. Count. I got to pause, take a step back. Remember, I advised you to try to estimate. So this is about 23 and 8. That's about 25. And why did I choose 25? Because I can do 3 25s pretty quickly in my head. I usually think about quarters. So 3 quarters is about 75, right? Therefore, the answer could not be 8,000 nor 809. It won't be 8 wholes or even less than a whole. The only place where that decimal point would make any sense to be close to 75, our estimate, would be in the middle of the 0 and the 9 to make 80 wholes and 92 hundredths. So again, you may count decimal places, or use the estimation technique, or ideally, the strongest students would be able to do both. And that's what I'll challenge all my students to do. All right, so what about combining decimal products with some algebra? I'm going to ask you to evaluate these. If you would like, you can pause, work it out on your own, and then come back. But I'll encourage us to use our mental math skills. So for instance, example A is multiplying A times B. We substitute in the appropriate digits, 2 tenths times 5. Now everybody knows that 2 times 5 is 10. But let's use our mental math skills here. Where should that decimal point be? I don't want you to actually write down any work. We see 2 decimal places here. Then there should be 2 decimal places in the end. Now notice I don't put the 0. You can. It's not wrong. It's just not necessary. But the other ways you can think about it, 5 pennies, 5 groups of 2 pennies would be 10 pennies, right? So that's why it would be the same as a dime. Off to example B, 2 times B times C. We can substitute those numbers in. Grouping symbols tells us 2 sets of 5 is 10. Now what about 10 sets of 1 and 4 tenths? Again, you can use your mental math skills here. 10 14s is 140, but we have 1 decimal place to move it. So instead of 140, it would be 14. Again, think about estimation. 10 times 1 is about 10. It's got to be a little bigger, right? Hey, check out part C. We have the product of AB. We just did the product of AB. That would be 1/10. Let's go ahead and add this mentally without writing it out, because I think we can take our place values here. Don't add 1 dime with 1 whole. Add a dime with a dime. Add the tenths and add the wholes, and you will get 5 tenths, 1 wholes, final answer of 1 and 5 tenths. So for these, I'm going to try to make the numbers a little easier. Check that out in your homework assignment, and you'll be able to use some mental math here, but you still see me writing the directions, the problem, the work, and the answer. It's just that I'm not going off to the side and showing multiplication or addition of decimals. Now let's look at powers of 10 here. I suppose we could go off to the side and multiply by 10 or multiply by 100 or multiply by 1,000. But many of you might already recognize this. Anytime you're multiplying by a power of 10, that's 10, 100,000, 10,000s, and so on, all you have to do is move the decimal place to the right, the certain number of zeros in that power of 10. So for instance, think about 2 times 10, $20. It's going to be bigger than that, right? Well, if we would simply move this decimal place 1 to the right, we could quickly devise that the product will be 27 wholes and 5 tenths. Similarly, with this next example, because there are 2 zeros, we're taking 100 sets of $2, which would be 200, right? but we also have those parts. So we're going to move it not once, but twice to get a final answer of 275. That makes sense. And if we multiply by 10 to the third power, or 1,000, being that there are 3 place values, we can move it once, move it twice, and then we're going to move it thrice, a third time. And since there's no number to hold that place value, naturally we'll put in a 0. So if we were to multiply 2 to the 7,500 times 1,000 without showing any work off to the side here, without rows and rows of zeros, we can find the product of 2,750. And I put that decimal in there just for effect, ladies and gents. I would not expect you to do it. Of course, the decimal is necessary here to show the difference between the whole pizzas and the parts of pizzas. So anytime you're multiplying by powers of 10, simply move that decimal place by the number of zeros. All right, with that, folks, I'm going to let you go. Don't forget, please write the directions, then the problem, then your work, and then your answer. And of course, the exceptions. You can scroll back in the video if you want. If it's a word problem, you do not need to write the problem, just the work and the answer. And I am asking you right here for problem number 37, or excuse me, page 37, 29 to 47 odds. This is mental math section, so only the directions, the problems, and the answers. Then when you get back to 48 to 55, go back. But again, if they're word problems, you do not need to write out the problem. I'll help you out as we get to class. Take your time, folks, and do well. Let's grow.